Electrostatics question number 1. The diagram below shows two identical metal spheres R and S, each placed on a wooden stand. R and S carry plus 8 mu c and minus 4 mu c respectively. First question, explain why the spheres were placed on a wooden stand. So why the stand is wood, right? So that's the question. We saw this type of question before, if you charge an object, right, if you want to keep the charge, you have to place it on an insulator, and wood is an insulator. So to keep the charge on the sphere, or to make sure that the charge does not leak to the ground, so that's why we use what? A wooden stand. Then now R and S are brought into contact for a while and then separated by a small distance. So this is now grade 10, right? So when two charged objects are in contact, they share the charges, right? And how do we calculate the net charge of each sphere? Q is equal to Q1 plus Q2 over 2, right? And then we will get the answer. Okay, let me do it for you. Okay, so this is the answer. You can see Q is equal to Q1 plus Q2 over 2. So when you are substituting, you must make sure that you include the signs properly. Okay, and so final answer is 2 times 10 to the power of minus 6 coulombs. Now in 1.3 they ask to draw the electric field pattern due to the two spheres R and S. So now you can see both of them are now positive, isn't it so? So because the question is based on this condition that they were in contact. So R is positive, S is also positive. So you have to draw an electric field pattern between two positive charges. So this is how your electric field pattern is positive from positive. So arrows are outwards. Okay. Shape is important. Then arrows direction important. Lines must not touch each other. Yeah. So consider all these when you draw the electric field pattern. Now now R is positive. So which is plus 2 mu c, or 2 times 10 to the power of minus 6. Okay, and S is also plus 2 mu c. Okay, right. So now what's happening? After R and S have been in contact and separated, a third sphere of charge plus 1 mu c, so this is plus 1 mu c, is now placed between R and S. So draw a free body diagram showing the electrostatic force experienced by T due to sphere R and S. So we are going to draw a free body diagram. So the force exerted at T. There is a force between T and R. Also there is a force between T and S. So when you look at the force between T and R, T is positive, R is also positive. So T is repelled by R, right? That means that force is to the right. Force between T and R. Okay. Similarly, what about the force between T and S? Here also both of them are positive. So T is repelled by S. So repulsion is moving away from S, means it is to the left, which is going to be F T S. Okay, so that gives you the the free body diagram. Next question 1.5. Calculate the net electrostatic force experienced by T due to R and S. So we need that net electrostatic force. So there are two forces acting on T, which is FTR and FTS. So once you calculate those two, then the net is going to be, since these two are in opposite direction, the net is going to be one minus the other one, isn't it so? Right. So first of all, let's calculate the force between T and R. So you can see the calculation. I calculated the force between T and R. So the distance must be the distance between T and R, which is 10 centimeter. Change it to meters is 0,1. Then I got 1,8. Similarly, I calculated the force between T and S. Their distance is 20 centimeters, which is 0,2 square. So there I got the answer 0,45 newtons. Then the total force. So when you look at your free body diagram, you can see it's one is to the right and second is to the left. Okay. So what I did is I did right minus left. Okay. And I got the answer 1,35 newtons. Since answer is positive, my direction is to the right. Okay. Now, so that is because the question says net electrostatic force. So we need the magnitude and direction. Okay. 1.6, define electric field at a point. You know the definition. 1.7, calculate the magnitude of net electric field at location T due to R and S. Means at T, what is E? That's the question. Okay. So when you look at the situation, here at T, we calculated that the net electrostatic force is 1,35. Okay. So to calculate E, if you have force, we can calculate E is equal to F over Q, right? So this F is 1,35 over what's the value of Q? Q is 1 mu C, because at T what is the charge? That's what we check. 1 times 10 to the power of minus 6. Okay. So when you do the calculation, you will get 1,35 times 10 to the power of 6 Newton per coulomb. So that's the answer. So this is, since it is 3 marks, actually we can do this easily. Otherwise, you can go for the longer method, electric field at T due to R, electric field at T due to S, and from there you can calculate what? The total electric field. But since we calculated F net, we can always go for E is equal to F over Q method. Question 2. Two identical negatively charged, this is a point, negatively charged space A and B having charges of same magnitude are placed 0,5 meters apart in vacuum. The magnitude of the electrostatic force that one sphere exerts on the other is this one. So this is the electrostatic force between A and B. First question, Coulomb's law. 2.2.1, calculate the magnitude of the charge on each sphere. So you have the force, right? You have the distance. To calculate the charge, we know we use, since you have the force, equation is F is equal to K Q1 Q2 over R square, right? So let me substitute. Okay, so this is how I substituted. I substituted the value of F, then K is our constant. Both charges are identical, so I represent both of them as Q. Then the distance is 0,5. So then I simplify it. Q times Q is Q square. I simplify, and then I got Q square as 4 times 10 to the power of minus 12. Then take the square root of both sides. The charge of each sphere is 2 times 10 to the power of minus 6 coulombs. Okay. Now 2.2.2, excess number of electrons on sphere B. So for sphere B, what is the excess number of electrons? Okay, so if you want to calculate the number of electrons, right, our equation is Q is equal to N times E, or N is equal to Q over E, right? So the charge of sphere B is minus 2 times 10 to the power of minus 6. You see why I said minus? They already said these two charges are negatively charged spheres. Okay, so that's why it's minus 2 10 to the power of minus 6 over E constant minus 1,6 times 10 to the power of minus 19, which is given in your formula sheet. So when you calculate this one, you will get 1,25 times 10 to the power of 13 electrons. So that is the answer. Okay, right. Then 2.3. P is a point at a distance of 1 meter from sphere B. So this is a point, okay, that's 1 meter from sphere B. What is the direction of the net electric field at P? So A is negative, B is also negative. Point P is always positive, right? So our focus is at point P, right? Always at the point, okay? So from positive to negative attraction, right? So electric field due to A is towards A. Electric field due to B is also towards B because it's attraction, right? So what is the direction? It is to the left. Okay. Now 2.3.2, calculate the number of electrons that should be removed from sphere B so that the net electric field is 3 times 10 to the power of 4 Newton per coulomb to the right. So if you are removing the electrons from sphere B, right, so then the electric field is going to change, right, and that is going to be this electric field and it is to the right. In that case, how many electrons should be removed? That's a question. So we must first calculate using the new electric field. We must calculate what is the charge of sphere B, right, because once you get the charge, that's where you can calculate the number of electrons removed, right? Okay, so let's calculate the electric field. Okay, so now since so A is negative, since electrons are removed from B, B is going to be positive, right? So let's have a look at, so when you look at the total electric field is towards right. This E is towards right, isn't it so? Right. So but when you are breaking it down, you can see the electric field due to A is still to the left because point is positive, right? This is the point P, right? Point is still positive. Point is always positive, okay? So the point and positive and negative is attraction, right? But positive and positive is repulsion. So this is how the directions are now, okay? Right. So let's write 2.3.2, right? So the electric field E is actually equal to EB minus EA, because when I explained in the other side, it says this is EA and this is E what? B, right? So we are taking right as positive. So EB minus EA. So let's calculate these separately. Okay, that's easy for me. EA is equal to KQ over QA over R square, which is 9 10 to the power of 9 times A is what? 2 times 10 to the power of minus 6, because there is no change in A, over what is the distance between A and P. Okay, so you can see A to B is 0,5 and B to P is 1. So we need the distance from A to P. So what's the distance now? 1.5 meters. Okay, so substitute 1.5 square. Let me do it for you. So the answer is 8,000 Newton per coulomb. Similarly, we are going to so this is A, sorry, B, ne? It's not A, sorry. Oh wait, it is A. Sorry. It is A, sorry. Similarly, we are looking for EB. Okay, EB is KQB over R square, but we are looking for QB, right? So we can just substitute K and R. Okay, let's have a look at the R. R is going to be 1. Okay, right. So now EB is 9 10 to the power of 9 QB, right? Now we can substitute in this equation. Okay, equation number 1. Okay, right. Our resultant is, when you look at your question, they said 3 times 10 to the power of 4 to the right. So right, we took it as positive, so it's still E is equal to EB minus EA, right? So this is 3 times 10 to the power of 4, that's equal to, what's our EB? 9 10 to the power of 9 QB minus 8000. That's what I got, right? Now you simplify for QB. So I got QB as 4,2222 times 10 to the power of minus 6. Okay. So before we calculated the charge of Q, what was the charge initially? The charge was 2 times 10 to the power of minus 6. It's minus, ne? Okay. So the initial charge of B was minus 2 times 10 to the power of minus 6. Now what is the charge? Final charge is 4,2222 times 10 to the power of minus 10 to the power of minus 6. Okay, so you remember in grade 10 we studied, if you want to calculate the number of electrons transferred or removed, we need to find out what is the change in the charge. N is equal to delta Q over E. It's the same equation, but we apply delta Q because we are removing it from this charge, isn't it so? So when you substitute as 4 comma what is the initial? Okay, so I substituted the final charge minus initial charge over E, right? So when you do this, your answer is going to be negative because of this negative sign. It's okay. What you need to, because number of electrons cannot be negative, so you write the answer as positive. That's it. Okay, 3,89 10 to the power of 13 electrons. Okay, so this is the number of electrons that they transfer to make the new electric field. Question 3. So we have 3 charges here, Q1, Q2 and Q3, right? Charges are also given. The distances are also given. You can see that. Coulomb's law in words, that's the first question. Second question, calculate the net force acting on charge Q3. That is this charge Q3 due to the presence of Q1 and Q2. So remember what we are supposed to do when you get questions like this. You first try to identify. So this is our Q3. Q3 is positive. Q1 is also positive, right? So the force between 3 and 1, that is force of repulsion. Q3 is repelled by Q1, means it's moving away from Q1. So this is the force between 3 and 1. Okay, then let's look at Q3 and Q2, right? So Q2 is negative, Q3 is positive, right? So 3 is attracted to Q2, means it's moving towards Q2, right? So the force is towards Q2, so force between 3 and 2, right? Then I told you, if you get questions like, if the diagrams are like this, then what is the resultant is in the middle, right? So and then the direction is determined by the angle theta. Remember that. So now we need to calculate F31 and 32, and then we apply what? Pythagoras to get FR. Let me do it. So you can now see I calculated F31, I got 3 newtons, F32 13,5. Then I apply the resultant square root of x square plus y square. So then I got the final answer as 13,83 newtons. So this is the magnitude. Here the question says net force, so that means we need the direction. So I told you in the previous example, the direction can be determined by the angle theta, right? So what was the equation for theta? Theta is equal to tan inverse y over fy over fx, right? So that means tan inverse according to our diagram, y is F32 over F31, right? And substitute and get the answer. Okay, so the answer is 77,47 degrees. So now when you write your final answer, we say FR is equal to 13,83 newtons, right? 77,47 degrees. So you see that angle theta is below the negative x-axis, isn't it so? So we can say below negative x-axis. That gives you the full marks. Okay. Question 4. You have two neutral spheres. Two neutral spheres M and N. They are on insulated stand. We are brought that into contact. So M and N are in contact now. And then there is a charge rod brought near to M, right? So when spheres are separated, it is found that 5 times 10 to the power of 6 electrons were transferred from M to N, right? Electrons were transferred from M to N. That means when electrons are transferred, M becomes positive and N becomes what? Negative. Question is, what is the net charge on sphere N after separation? So since this much electrons are removed from M, that N received that much electrons, isn't it so? So that means to calculate the charge of Q, charge of N, Q is equal to Q is equal to N times E, number of electrons times E, right? So how many charges are transferred? 5 times 10 to the power of 6 times minus 1,6 times 10 to the power of minus 19, right? And that gives you minus 8 times 10 to the power of minus 13 coulomb. So that is the answer for charge of N. Write down the net charge of M after separation. So M transferred, or from M this much electrons are removed. That means it becomes positive, right? So charge of M is actually same as N, but since it's removed, it's positive. 8 times 10 to the power of negative 13 coulomb. Okay, right. Now we have M and N arranged like a straight line separated by a distance of 15 centimeters. Then P is a point which is 10 meters from N. Right. We want to calculate the net electric field at P due to M and N. Right. So we identify that M is positive and N is negative. Point P is always positive. Right. So let's first check what is the direction, right? So this is our point. Point is positive and M is also positive. Attraction or repulsion? Repulsion means moving away from M. So electric field due to M is to the right. Now check again point P and N. Attraction means it is towards N. So the electric field due to N is towards left or towards N, right? So the net electric field is going to be, you know what it is, right? Because they are in opposite directions. So total electric field is going to be EM minus EN, right? So let's first calculate EM and EN, and then from there we are going to calculate the total electric field. So for calculating EM, so let's go for EM first. EM is equal to K QM over R square. K is 9 times 10 to the power of 9. Okay, let me substitute for you. So I calculated EM and EN. You see charges are same, but distance between M and P. Distance between M and P, 15 plus 10. 25, right? 25 centimeters. I changed it to meters, 0,25. Okay. Then between N and P, it's 10 centimeters. So it's 0,1. So I got this one, right? So the total electric field is, I said EM minus En, right? So 0,1152 minus 0,72. Okay, and then the answer is minus 0,6048 or 0,60, round off to 2 decimal place, Newton per coulomb, minus. I took right as positive, so left minus means it is to the left. Okay, so this is the final answer. Question 5. So now you can see it's a very small graphite coated sphere P is rubbed with a cloth. It is found that the sphere acquires a charge of plus 0,5 mu c. So the charge of P is plus 0,5 mu c. So we first need to calculate the number of electrons removed from P during the charging process. That one is easy. Number of electrons you can calculate using N is equal to Q over E, right? What is the charge? 0,5 mu c. Mu is 10 to the power of minus 6 over electron is 1,6 times 10 to the power of minus 19. Okay, you can leave it as negative because it's an electron, right? So electrons were removed, right? So then when you calculate, you will get 3,125, which is 3,13 times 10 to the power of 12 electrons. I told you that when you get electrons as negative, you write it as positive, or you can avoid substituting the negative as for electron. It's up to you. Okay, so this is the final answer. Now the next question says this charge P is now suspended from a light inextensible string like this one. This is the situation now. Another sphere R with a charge of minus 0, this is the charge is minus 0,9 mu c. So this one is plus 0,5 mu c, right? So brought close to P, then you can see P moves because it's a traction, right? P move towards R and it is now at a distance of 20 centimeters from R, but now the system is at equilibrium and the angle is 7 degrees. So we need to draw a free body diagram showing all the forces acting on P. Okay, so when you look at the free body diagram, like P, right? When you look at our P, you can see there is a string, the string, right? So that is tension. Then between P and R, there is a force of attraction, electrostatic force. And then since P is suspended, you know there is weight, right? That's why it's 3 marks, okay? So when you draw the free body diagram, tension, this is Fe, and this one is Fg, right? Or weight. Okay, right. So these are the forces acting. Okay, and then now calculate the magnitude of tension in the string. So when you want to calculate the tension, I am using this method, right? So this is our Fe, this is the tension, and this is Fg, right? So what we are going to do is we are going to split tension into its components, which is Ty and Tx. They gave you this angle as 7 degree. That means this angle is 83 degrees, isn't it so? Right. So Tx is equal to, because I told you in this way, Tx is equal to T cos 83, because for 83 this is the cos, right? Then Ty is what? Ty is T sine 83, right? So we want to calculate tension, right? So system is at equilibrium means right side force is equal to left side force, isn't it so? Fe is equal to Tx. So first calculate Fe. Fe is equal to K Q1 Q2 over R square, which is 9 times 10 to the power of 9 times, what's the charge? 0,5 and 0,9 mu c. 0,5 times 10 to the power of minus 6 times 0,9 times 10 to the power of minus 6 divided by distance is 20 centimeters, means 0,2 square. Okay, and then you will get the answer. Okay, so the answer is 0,10125. Okay, so now we know Tx is equal to Fe. What is Tx? T cos 83 is equal to Fe, right? So Fe is what? 0, 10125. So divide both sides by cos 83. Cos 83. T is equal to 0, 0,83 newtons. That is the answer for tension.